So in this video, we will understand in detail the significance of different parameters in first order system. In the previous videos, we have seen how to derive the response of the first order system and how does the steady state error and the response of the system varies as we keep on changing the input, that is for unit step input, unit ramp input and unit impulse input. Now, in this video we will understand in depth about the different characteristics of a first order system. For that, first we need to understand the definition of pole. Pole we have already studied. Okay, but now we need to differentiate the pole into system pole and unit pole. So we need to understand, sorry, not unit pole, input pole. So now we need to understand these concepts, because only if we understand these concepts we will get to know how these system pole and input pole affect the response of the system. For that, always whenever we say a transfer function, it is equal to output, that is C of S by input R of S. So whenever we are saying a response, system response, so the system response is equal to T of S is equal to transfer function T of S into R of S. Now this transfer function T of S, this is with respect to the system. If you are considering any system, T of S will be T of this will be associated with the system that we are analyzing. So T of S will be associated with a system. As the system changes, T of S changes. But normally if we are taking one single system, the T of S will remain as it is. And R of S is dependent on what type of input we are giving. R of S will be associated with the type of input. With the type of input. Now, both of these, T of S as well as R of S, will be represented by the S polynomial, numerator by denominator. So you can have T of S is also a function of S. So it is given by certain polynomial, S polynomial. Even R of S is a function of S. So I can write T of S as, for example, I'll just take an example so that way it is easier to understand. So we have this system. This is my system, and the system is represented by a function S plus 2 divided by S plus 5. And the input to this, that is R of S, is equal to 1 by S. So your T of S, that is with respect to the system, transfer function of the system, this is equal to S plus 2 by S plus 5. So we can see that this function T of S is having certain pole. The pole is located at S is equal to minus 5. So the pole is at S is equal to minus 5, and the same transfer function has a 0, which is located at S is equal to minus 2. Now these we don't, it is not a complete response pole and 0. They are simply system pole and 0. We call it as system pole and 0. So the pole and 0 associated with T of S is called as system pole and system 0 respectively. So I'll just write it here. the pole or 0 associated with system transfer function, that is T of S, is called system pole or 0. That is the first concept. Second one is the input pole. So input R of S is equal to 1 by S. So you can see that there is no 0 here. This look at this transfer function. This is a kind of transfer function only. Okay, so this is the one of the type of transfer function. So here you can see that there are no zeros and there is one pole which is located at S is equal to 0. So this one pole we call it as input pole. Call it as input pole. So the pole or 0 associated with the input transfer function, we call it as input pole or 0. The pole or 0 associated with input transfer function, that is R of S, is called input pole or 0. So this is how we define the input pole, the input 0, the system pole and the system 0. Just a minute. Okay, so now we'll understand the next part of the analysis is how do these system pole and system 0 will affect the response. That we will see it in the next video.